It's a big part of town.
Get a remote on your next one.
You're right, GPS chip and a remote. Oh my God, I'll probably trip and break my face. Here's the deal. Remember the last line we had a slope of 1.125. Let's say that we wanted to use that slope, and we decided that it had to go through this point and the point over there. I'm going to try to draw this as straight as I possibly can. This is probably going to be woeful. Okay. It's not bad. It's not bad. Now, anytime you force a line to go through data, like Jeremiah's idea was fantastic, but anytime you force a line to go through the data, you're not going to hit the data points, all of them perfectly. Unless the data themselves are perfect, which they never are. So, you're going to have what are called misses, M-I-S-S-E-S. They miss the data. They're actually called residuals in statistics. Part of your program I just gave you deals with residuals. Residuals are how off the line is from the data point. So if you look at here to here, that will be, and that's called a residual. That's a residual. This here to here, that's called a residual. And this here to here, that's called a residual. Okay? Now, if you add up residuals, the sum of all the residuals, this is a positive one, obviously. These are negative ones. They're going to sum to 0 on average, just like they did in 243 and 244. Deviations from average always zero out. We'll learn why in 243 and 244. It's not important right now. What the best fit line is sometimes called formally is a least squares regression line. A least squares regression line. And here's where the squares comes in. What you do is you calculate the area of these little squares right here. If you add those squares up, that adds up to the sum of the squared errors. Now when I say error, I'm giving you a 2-minute introduction to this. The video is much more in-depth if you want to go that route. You don't have to, trust me on this. What we want to do is minimize the size of those squares, hence least squares. If the size of the squares is as little as possible, then the line fits the best. We don't call it a perfect fit line because it can't perfectly fit unless the points themselves are perfectly linear. But what you want to do is you want to get the line seated in there so that those off squares are as tiny as possible overall. So you can see right away that line would be better than, say, for example, this line. Right? Pretty obvious that line's going to be a lot worse. The first 2 points have no residuals at all. But then the next residual itself is going to take care of, there's more error there than the entire other model. If you add more, it's good. But then the question is, then you have to get fine. It's pretty obvious to see that our blue line is better than the green line. But our blue line isn't the best one. The best one is this one. And you see how close they are? But the question is, how do you get that one? See, this one, it belies a little bit of logic, because you actually have to use calculus to do this by hand. Okay? I'll show you what you have to actually do. You have to do this up here to calculate your equation. I'm not going to make you do that. Hell no! Hell no, you're not doing that. There's a function, though, on your machines, on your TIs, that allows you to do this. And that's what I want to spend the next, say, 20 or so minutes. I made a little booklet for you guys. It's a little booklet entitled How to Make a Scatter Plot and How to Perform a Linear Regression on the TI-83 or TI-84. And I brought a bunch of them with me. I'm going to hand them out to you, and we're going to work in little groups or individually. And we're going to figure out how to input this data into your TI, how to get that scatter plot like this, and how to figure out that line right there without using that crap right there. And then when we get done, we'll come back and we'll answer these questions right here. And these questions right here. But first things first, let's get comfortable with our TIs. So if you have them, get them out. If you don't have them, just sit with somebody who has one so you can see the steps. If anybody wants to use like an app on their smartphone, we could probably figure this out right now, how to do it. I mean, I probably don't know your app, I probably learn it with you. So, your choice, okay? But I did make a booklet for those of you with a TI.